Question 10. So we've got to find the difference between the lower bound of t and the upper bound of t. So clearly we've got to work out both bounds. So the upper bound, to maximise t, we have L as big as possible and G as small as possible. Now I've worked out the various boundaries of L and G here. So to get it as big as possible, we want L to be as big as possible, 1.365, but G to be as small as possible, 9.75. So substituting that in and using our calculator, the biggest that t could be is this number here. Now to minimize t, we want L to be as small as possible, G to be as big as possible, small and big. So the smallest that L can be is 1.355, the biggest that G can be is 9.85. Substituting that in, we get this as the lowest bound. So obviously the difference between these two is just 1 take away 2, which is this number here. Now question 11. So quite tricky part B, I think, but A is alright. So the upper bound is going to be 6.75, the lower bound 6.65. Now we're told that the area of the rectangle is 26.9 to 3 sig figs. We've got to calculate the upper bound for the width of the rectangle. So here's my rectangle, here's my width. Now if I want this to be as big as possible, I need to have the biggest possible area, 26.95, and divide that by the smallest possible length. That's going to maximize my width. Biggest area divided by smallest length. Okay, smallest length from here. So 26.95 divided by 6.65 gives me this when I display my whole calculator. Now part 2, we're going the other way. We're now trying to work out the lower bound for the width. So how do we make this as small as possible? Well, we would start off by having the smallest possible area, which is 26.85 from this, but the biggest possible length, so small divided by big, and that gives us a the smallest that the width could be of this number here, 3.97777. So part C, part 1, write down the width of the rectangle to an appropriate degree of accuracy. Well, to do this you compare the lower and the upper bounds and you go as far as you can where both agree. So to the units value, this rounds to 4, this also rounds to 4. So we can certainly say they agree to the units column. Now what about to 1 decimal place? Well, this upper bound is 4.1 to 1 decimal place. However, the lower bound is 4.0. So they do not agree to 1 decimal place, so you can't go as far as that. So we can't be very accurate at all. We've just got to say that the appropriate degree of accuracy is just 4 centimeters. Okay, give a reason for your answer. Well, we can't be any more accurate than that because the upper bound and the lower bound do not agree to 1 decimal place. In other words, the units is as far as we can go. Question 12. So, CLAW to start with, so 4x plus 12 equals 6, then fairly straightforward algebra. To how do we undo an adding 12? We take away 12. How do we undo a times by 4? We divide by 4. Simplify, we get x being minus 3 over 2. Now for part B, we've got to make t the subject. So we start off by working our way up to the t. So we undo the adding of u by taking away u, and then we undo the timesing by 5 by dividing by 5. Remember, to make the point that everything is divided by 5, it's just simplest to do v minus u all over 5.